Morning everybody. We're going to have a look at how to plan a program that uses a function that we need to code ourselves. So let's just recap a little bit. We use functions to break up a big problem into smaller sections. These functions will then calculate something specific and return that value that had to be calculated. And we saw how pre-existing functions can be used. The power function of the math class, for example, was coded long ago. It's made available to all programmers, and now if I need to calculate the power of any number, I simply need to call the function. I don't need to worry about the steps that the function follows, how it actually does its job. All I need to worry about is what data to provide, and then I get back the result. And in the same way, any function that we code will be used. Our functions will just not be made available to the general public at this stage. Okay, so for now it might seem as if we do quite a bit of extra work because we code a function in a specific program, and then in the button event procedure we call the function to do its job, and then it's all over and done with, and we move on to the next program. Remember, we're in the process of learning to use functions, learning to code functions, and learning to plan for functions. So at a later stage in your life, you're going to code functions that would be made available to the rest of your colleagues in your company, for example. Same as what the math.power function is used currently. Okay, so for the first illustration, I've got a planning document that's already filled in. I'm going to make a second demonstration where I slowly and carefully fill in everything that we need. So if I read the program, it's program 12 that you've got on Vutela. It's a difference application. Do the planning to calculate for a program to calculate the difference of two numbers. The user must enter the two numbers and then click on the, sorry, this is spelling typo, click on the calculate difference button. The button must display the result of the calculation in the label result label. Okay, and then it says plan and use the following function. There we go. Function's name is given to us, so if a name is given, that is the name to use. Calc difference, to calculate and return the difference of two numbers. The function must get the two numbers and send the difference back. And now it says subtract the smallest number from the largest number. Okay, so I've got a function that's got to get two numbers, and if I calculate the difference, I need to subtract the smallest number from the largest number. So if I've got 20 and 15, then I need to subtract 15 from 20 to give me a 5 result, so that I have always a positive result, depending on the two values. If I need to subtract minus 5 from minus 10, I definitely won't have a positive result, but smallest number from the largest number. And my program must get two numbers. The program must display the result. So in the button calculate event procedure, we'll need to get the two numbers, then call the function to calculate the difference, and then display the difference in label result. The first thing that you need to do would always be to plan the function. We're going to use a document like this for the function. I just notice the function name must be calculate difference. So function name over here must be the same. The function will always receive data and return data. A function only returns one value. That is, by default, the norm. Okay, so the norm in programming is that the function calculates and returns one value. It might take a few steps to get to this one value, but a function normally returns only one value. It can receive many items of data. So for this function, we need to always go read this description carefully. The function must get two numbers. So function will get number 1 and number 2. We stick to the variable names that we know. The function must send the difference back. So the function is going to return the difference. Now we've got an extra instruction, specification. Subtract the smallest number from the largest number. We'll get to that in a moment. So, right, for starters, I can go and specify the data received and the difference, the data returned. And no data is given, so I can just get different values. So if the number 1 was 10, number 2 was 8, my difference needs to be 2. If I've got 45 and 55, the difference is 10. 30 and 22, the difference is 8. If you can't think of other variables immediately, you can think of the steps first. So, right at the start, it would always be declare the variables. And now if I want to subtract the smallest value from the largest, or the smallest from the largest, I need to know what is the smallest value and what is the largest of the two values. Then I can easily calculate the difference, take the largest, subtract the smallest, save that in difference, and I can return the difference. So a function will normally have as its steps declare the variables and return the result. The steps here that you will need to come up with, you will need to determine the which steps. These would be the steps to get from the data received up to the data that must be returned. So for my function, I need to go and see which is the smallest, which is the largest variable. So how will I do that? I've got a math.minimum method. How will I know what's the largest value? The math.max method. Okay, take note. In a little while you're going to start with decision statements. And then it would be optional for you to either use the math and min methods or use your decision statements. But using then the planning, the steps and the which variables, what data returned, data received, we write down the steps of every function that the program must use. So this program only uses one function, one planning step. The white part in the middle, the other variables, that's going to be optional. Sometimes the function doesn't need to use other variables to get from the data received to the data returned. Take note that a function under normal circumstances, so this is again any normal function that you would code does not, I can highlight that, access the user interface controls at all. So a function is not going to get data from a text box. It's not going to display data in a label. Let's do it like that. No data from a text box. We're going to use the what would be called parameters. These we're just going to specify at this stage. The function receives this data. At a later stage I will show you how to program this. So a function will never access a text box for input data. We only send data via parameters, and that's the received section. And we're going to have absolutely no data displayed in a label. Return data via the function. That data returned section. Okay, this one over here. So a function doesn't access the user interface controls at all. I get my data via parameters. It's this data received section that we've got over here. And a function will never display data in a label. We are going to return the data via a function. Let me explain this to you. The math.power function, for example, it can't go and display something in a label because when they coded the math.power function, they don't know in which program the function would be used. So the function returns data via the function itself, same as what math.max returns data and I save it. Math.min returns data and I save it. Now it's up to me to use it as I need to. So under normal circumstances, a function never does that. I get all my data via the function itself, the parameters, and I return the data again. Never access any user interface controls. If I go have a look at the program now, let's just make this a little bit smaller. I need number 1 and number 2 as my input variables. This is now for the button that would calculate the difference. So this button will access the screen, talk to the user, get the data from the user. I'm just going to delete this line. There we go. Okay, so I need two variables, number 1 and number 2, to store number 1 and number 2 that the user entered, and the user interface controls would be txt number 1, txt number 2. I take these names and I put txt in front to show that I'm using a text box. Later we can use other controls. Output, they said go and use LBL result, and a label name was given, so that means the variable will be result. What's the purpose of the variable? It will need to store the difference between two numbers. And at this stage I can determine my test data rather easily. So 10 and 8, the difference would be 2. 45, 55, the difference would be 10. 22 and 30, the difference would be 8. Take note, those values I'm going to give to the function, so I use exactly the same test data. have a look at the steps for the button. Declare the variables would always be the first step. Accept two numbers. So I'm going to get number 1 and number 2 from the user. And now I need to call the function to calculate the difference. Just correct the function name. So, first important part, where must the result be saved? It's got to be saved in the variable called result. Then I will always specify the name of the function first. So, result equal to calc difference. And now this must correspond to data received. Okay, the function wants two numbers, number 1 and number 2. So I need to send number 1 and number 2 to the function. This is the data that would be sent to the function, and we call these parameters. Afterwards, we're going to display the difference. You can also specify display the result, because the variable result would store the difference. Both of them would be okay, would be fine. Okay, so this first demonstration shows you a program that's already been filled in. We first fill in the planning for the function. Take note of these important steps, and then we go fill in the planning for the button. And sometimes a program might have more than one button. Then we fill in this entire planning per button. Thank you very much.